Assalamu alaikum wa rahmatullah. Hi everyone. In this video we will be working on question 5 from the coverage of a grade 11 elite for term 3. So in this question we have a function defined by f of x equals x e to the power of 1 minus x for all real numbers x. Part A, find each interval on which f is increasing. So to find the intervals on which the function is increasing or decreasing, you have to find the critical points first. So for part A, So for part A, we need to find the derivative of the function f prime of x. We have x to be the first and the exponential is what? The second. So we must apply the product rule. So differentiate the first, which is 1, leave the second. The first is 1, leave the second, plus leave the first and then differentiate the second. The derivative of e to the power of 1 minus x is e to the power of 1 minus x times negative 1, the derivative of the power, enough. Let's rearrange it. So f prime of x equals e to the power of 1 minus x minus x e to the power of 1 minus x. And as you can see, there is e to the power of 1 minus x in common. So f prime of x, we can factor it out. So this is e to the power of 1 minus x. And then when you factor it out, that leaves you with 1 minus x. And to find the critical points, we set it equal to 0. We set it equal to 0. Now we know that the exponential is never 0. This is never 0. So that means 1 minus x is 0, which gives x equals 1. This is the critical point. After that, you have to investigate the sign of the derivative on the number line. This is the number line. You have 1 here, and let's check the sign of f prime. If you choose a test point bigger than 1, if you choose a test point bigger than 1, like 2 for example, it will be negative. And if you choose 0, that would be positive. I'm substituting those test points into f prime of x. Be careful. Now, positive, it means that the function is increasing. Negative, it means that the function is decreasing. So if you go back to the question says find each interval on which f is increasing. It's increasing from negative infinity all the way to 1. That would be the answer of part A. Or you can just make the one here included. That's part A. Okay, so looking at part B, it says find the range of f. This is pretty simple because the range is always associated with f of x or y. So the maximum value for f of x, which happens at 1. So we need f of 1. If you plug in 1, that would be e to the power of 1 minus 1, which is 1. Okay, so this is the highest value the function could ever have, right? And then you check the limit of the function as x approaches negative infinity, because we are looking for the minimum f value that is given also negative infinity. So the range of this function goes from negative infinity all the way to 1. This is the range of the given function. Okay, part C says find the x coordinate of each point of inflection So when the question says inflection, you need F double prime. So let's do it here. So F هذا part C. F prime of X, we found it. It's where did we write it? We wrote it up. It's here. E to the power of 1 minus X, right? Bracket 1 minus X, okay? So now let's go ahead and find the second derivative. To find F double prime of X, you need to apply the product rule. Differentiate the first, it's minus e to the power of minus x. Leave the second, which is 1 minus x, plus leave the first, e to the power of 1 minus x. Differentiate the second. The derivative of 1 minus x is minus 1. Let's just rearrange this. F double prime of x equals to what? Well, we can factor out e to the power of 1 minus x. That leaves us with minus 1 minus x plus negative 1, right? Now to find the second derivative, you need to set it equal to 0, but let's rewrite it first. F double prime of x equals e to the power of 1 minus x, and this is simplifies to what? Minus here. This minus goes to the 1. This minus goes to the 1 and it goes to the minus x. So minus minus x, it's x, and then minus 1 minus 1, which is e to the power of 1 minus x bracket x minus 2. Now when you set it equal to 0 to find the inflection point, again we said the exponential is never 0. That means this bracket is 0, يعني x equals 2. So the inflection point, or the point of inflection, is at x equals 2. Now going back to part D, it says using the results found in part A, B, and C, sketch the graph of f in the xy plane provided below. Okay, now first of all, we know that there is, if you look at this chart, just 1 second, let me highlight this chart. If you look at this chart, there is a maximum at x equals 1, and from part B we found that f of 1 is equal to 1. F of 1 is equal to 1, and this is a maximum, so it has to be a horizontal tangent here. It has to be a critical point. Now we know that the function before this point is increasing, right? And after this point the function is decreasing. The function is decreasing and it is approaching what? It is approaching the x-axis. It's approaching the x-axis. And the function here is what? It's decreasing. But what is f of 0? If you find f of 0, it will be 0. So the function passes through the origin and decreases this way. So that would be a good or a rough estimate for how the graph looks like. This is the first question in the file of question 5, FRQ. This file has 4 questions. They are arranged in order of, they are arranged according to their importance. So question 1 is important, then question 2, and so on. Good luck.